Hello there. Here's next one in the series of lunchtime electronics. I don't know quite whether it will be a lunchtime or not, but we shall see. What we have here is an LED spectrum analyzer. It's all surface mount components, so it's a little bit more tricky than using full-size devices, but there's nothing to stop you using full-size devices if you want. It's just got quite a lot of repetitive soldering, and the fact that the parts are small. The board is double-sided. On one side you have the LEDs, and let me just tip those two LEDs off without losing them. There we go. And on the other side you put all the other components here, and basically it's just a matter of soldering them down. Now the kit doesn't come with instructions, but there are instructions available from the sellers and on the designer's website, although they can be a bit tricky to find because their search engine works in Chinese as opposed to English. But apart from that, what else can I say? It is the pictures themselves are actually quite clear, and it shows exactly what to do. So easiest way to describe it is for the LED side, you put all the negatives to the Y, and all the positives go that way basically. So if you take the Y as a negative, so it's positive, 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 and go from there. So I think I shall start soldering these and probably pause so that you don't get bored watching me solder lots and lots of identical LEDs onto a circuit board. All I'm doing here is just adding a little bit of liquid flux to make the soldering just a tad easier. It just makes the solder flow. What I am going to have to do is I am going to have to check the polarity with my magnifying glass because I can't see that well. There we go, get in there. You might want to also use a pair of very fine tweezers like these. You can buy a whole set of these from either AliExpress or Banggood, and they come to about £3 or £4. And if you deal with surface mount components a lot, then really it's the only way to go. You're going to need them sooner or later. They have all sorts of different types. You get the really just sort of sharp, pointy ones. Don't drop them on the leg, by the way, because it does hurt. Those points are very sharp. Or you get flatter ones, rounder ones, depending on the components you're trying to handle. I actually like the very pointy ones for most jobs because you can generally just get hold of most components and solder them like that. So that's what I'm going to do. So we've put the first one on. I'm just going to rest that there for a second. I'm going to pick up a small piece of solder. Let's move that off the component, and let's see if I can do this. Tip's dirty. That's what happens when you leave it around. Let's just see if I can flow a small bit of solder on the end of the LED and the pad, just like that. And then turn it around, just do the other side. Are you going to flow? It looks like it's flowed. Yep, that's flowed. Thought it would. Right, so let's turn this LED over. Now, it might look like a fairly easy job, but as I say, you've got 64 of these things to do. There are several techniques you can actually do when you solder these things. You can either say you put the flux on, put the first component on. I've seen people do heating up the first pad and the second pad, and then just melting the device into the solder. Let's do the other side. Like so, just to flow it on. But I find that it tends not to sit as nicely when you do it like that. It tends to I don't know. See if I can get a close-in view of this. See if I can get the focus to work on there. As you see, you just about. Yeah, let's see. I don't know if I can get any closer, or will it focus if I try it manually? Yeah. The only problem with the flux I've got out the pen, as you see, is it does leave a brown residue, which you just clean off with isopropyl. So, as I say, rather than have you watch me solder on all 64 LEDs, I'll do that, and then I'll come back when we're ready to turn the board over and go to the other side. Speak to you soon. Okay, here we are. Just soldering the last few bits of LEDs on, the last legs of one side, and then the LEDs are done. And I know it looks really messy at the moment, but that's just the flux. Once that comes off, it will be gleaming white again. Okay, so that side's done, and it looks like they give you 4 extra LEDs. Either they think you're going to blow them up, or they just think you probably knocked some off the table. So there we go. What I'll do is I'll turn that board over now, like so, and we can start to work on the other side. Now what I will do is I will close the picture that I'm looking at on my laptop at the moment and find the next one, which tells me where everything is. There we go. Yeah, right. So we need 33 ohm resistors for R's 1 to 6, 10 and 11, which are the ones coming off the chip. Do I solder the chip in first? 6 of one, half a dozen the other, really. I suppose I could. Let's do the obvious first. Just come on. Come on, flux. There you come. Just a nice line of flux there. And let's get the IC. And pin 1 goes with the dot. So, just make sure that's nicely aligned. Needs to come just round a tad. Everything's on the pads. So what we'll do is I will solder one at this end first to clean the tip again. Let's just make sure everything is straight. And the remaining solder that's on there should be enough to do that pin there. And then it's just a matter of soldering all the other pins in place. So let's what you've got to be careful not to do is to over apply heat and also to actually make sure you don't get solder bridges. See that leaked onto that tab there. Now at least that's just the capacitor tab. Let's turn it round and do this side. There we go, 1, 2. You've got more on the resistor pad there. Having the solder bridge. Having the extra flux is a real help, because it really does help the solder flow between the components. Now what I'm going to do is I'm just going to check that there are no bridges. I've actually soldered every pin, which I have. They're all good. Yeah, so now we can work on the other surface mount components. Where I've knocking the microphone, knocking everything. What time? Oh, it's 1:45 in the morning. No wonder. Oh, we do love doing these things late at night. Let me just get a bit of solder wick, and I'm going to clean that pad where I touched the iron to. And that one. Right, just to make it easier to lay things flat. Now, if we start with the smaller components first, we have some capacitors, which 2, 4, 8, and 9, according to the instructions. That's a resistor. That's a resistor. It's got 10 microfarads and 1 microfarad, but I only see one lot of capacitors. Oh, this is awkward, isn't it? Not a problem, because I can get them out my own stock, but doesn't make a good start for the kit, really. So let's have a look at what we've got here. 330, which is 3 with no more resistors. So that's the 1 to 6 and 10 and 11. Okay, so 1 to 6 and 10 and 11. So that's those 8 there. And they give you 9. Okay. So let's just peel back the plastic. Plonk them out. Like so. Flux. Let's just dab the flux down. Come on. When you don't want this flux to come out, it floods out. When you do want it to come out, it stubbornly refuses. Okay. Actually come out? Yes, it has. Right. So, put the flux down there. Let's start laying the resistors on the board. And we'll solder those up. Just really better if you have them all the right way up. That way you can see the values on them. Yeah, they do work the other way up. It's just a matter of neatness, ease of identifying what you've done and what you haven't done. Now, obviously, if you have a full SMD workstation, this will be quite crude appearing to you guys. But those of us who don't, those of us are still in the Stone Age with heat-up irons and magnifying glasses because we're old. You guys, well, I do these with the same sort of tools that any hobbyist can buy. I know I'm using a Weller soldering iron, and the reason for that is because I've had it for years. It's probably one of the better investments you could make, is buying a decent soldering iron. It will last you a very, very long time, and it's, I think in how long have I had that one? That particular one I've only had for about 5 years. But the one previous to that, the only thing wrong with it is the heating element went, and you can actually get spares for them. The Weller irons do come with spares, so I could have repaired it, but it turned out that it was cheaper on eBay to get this full unit second hand than it was to buy the heating element. So there we go. I do actually keep a stock of new tips for them, because there are, it's a consumable. People don't realise that the tips do wear out. They do die. So let's do this gently. Try not to knock everything off the board. So heat the pad, flow the solder. There we go. See, again, the reason I only do the one leg to start is for instances like that, where it grabs. I can then get the tweezers and actually melt it into position, and also then it means that you can make them a little bit straighter. If you don't like the presentation of them, as it were, you can turn around and say, I want to make that one straighter, or it's hanging over the pad a little bit. You can straighten it up before you solder the second leg. See, that one moved because I put too much heat on it, but we caught it in time, because that's what will happen with these. You will actually get enough heat to melt both ends across them. And that one's lifted up, so I'm just going to apply the heat, and you can just hear that click down. Let's just make sure that one's good. See, there's a little bit too much solder on the back end of that one, so just trying to flick a bit off with the end of the iron. Sometimes you can do it, sometimes you can't. Click down as well. So again, I'm just going to check that they're all soldered and there are no bridges. Yeah, not as pretty as a machine, but I'm not a machine, so we can go with that, I think. So we've got these two resistors here. Now the schematic shows 2 of R7 and R8 and 2 of R12, R13. So let's see, when we open the lid, what we've actually got in there. Three, 3, 4, so it's 33 with 4 zeros, which by my calculations makes that 330k, which makes them R7 and R8. Okay, so let's tip the pair of them out. Come on, boy, out you come. There you are. So R7 and R8. First of all, I suppose I better find them on the board. R8's there, and R7's there. Okay. So again, upper flux. I know you can get all these different types of surface mount fluxes. Where did that one fly off to? Yeah. It shot across the table to there. There we go. So R8 can sit there. You can get them either in these or the official Keister pens. I don't know if they're made by Keister, but they're made in China. Or you can get little bottles of liquid flux. You can get paint brushes with it on. You can get it in syringes with paste. I've actually got a small bottle with a brush, and I've got a couple of tubes that are like syringes. No, don't sit on the soldering iron. I'll have to sit down. See, I know in the factories when they do this, all the components are placed. There's a little blob of adhesive underneath them, and then they all go through a bath of solder, and it gets melted on in one sort of fair swoop, at just enough temperature to melt the solder, but not the adhesive. And again, quick check. Yep, they're both in there. Right, so we've got another 2 resistors here. Conscious of the timer on the camera. I think this may not quite be a lunchtime project, maybe over a couple of lunchtimes. Obviously, the surface mount work is something you couldn't do as a sort of quick rush job unless you are sort of fully kitted out. There's one jumped out. There's the other jumped out. And my hair's falling out everywhere because I'm getting old too. Now, what does that say? 102. So that's our 1K resistor, which is the other 2, which is 12 and 13. So let's find them on the board. R12 and R13. So there and there. 12, dial 13. Typically, now that spike has happened because there's not enough flux there. So, dropping the iron. It's never a good thing. At least it's not a blowtorch or anything like that. Although it's still quite hot. Typical, isn't it? You're looking at the timer, and the timer's got enough time to finish, yet the battery dies on the camera. So, sorry, you missed me soldering on the last couple of bits. Just having a look through the circuit diagram on the original Chinese website, C2 is meant to be a 10 microfarad capacitor in the DC power supply chain. Now, they don't seem to have bothered with it on this board. It just seems to be sort of redundant, so first of all I'll try it without putting one in there. It's just, as I say, it seems like a redundant thing, but before I do anything else I will do cleaning up the board, because that's always a nice thing to have, is no sticky tacky residue on it. So I should get my jar of there we go, not nice to drink stuff, because it's not, and all I do is I get one of my old toothbrushes. Where are my old toothbrushes? They were over here before. There's one. And just dip it in, and alright, drop the whole thing in. That should give it enough of a coating, and then just clean all the flux off, and it should come off nice and easily. Obviously I could use clean isopropyl every time, but it seems pointless, because unless it evaporates, it's still good for another set of cleaning. And as you see, it brings the surface of the board up nicely. Just a few bits in there that quick scrub with a fingernail. That's better. And again on this side. And it should polish up all nicely. I've seen the industrial flux cleaning bars, and in fact I've used them, full of trichloroethylene, and very nice, very toxic. This stuff, at least if you unless you spray it in your eyes or drink it, it's relatively safe. And then all we do is we just get a bit of kitchen roll and tap the board dry for a bit, close that. I don't want it to evaporate away. Get rid of that. And then put it in its space, there. And just dry the board off. The board should evaporate dry fairly quickly anyway, without leaving any sort of sticky residue at all. And I'll get a close-up of that if I can focus in. There you go. As you see, the soldering is actually quite neat. There's a little spike on that one, but generally that looks pretty good, even if I do say so myself. and on the other side, again, a close in. A little bit wobbly there, but yes, I am dealing with it. Looks like I've missed the end of that capacitor, which I shall just... Yes, I have. So there you go. Always worth a check. You never know what you'll find. So let's just put a solder on there. Not too much. Let's check that again. Yeah, that looks better. Yeah, that's fine now. So that's all of them done. That's everything there. I think, let me focus you back in on the bench there, like so. Move the rubbish to one side. Move the spare components up there into a neat little pile. Right, then we have to read the instructions. It needs to be powered from 5 volts, I believe it said in the instructions. If I scroll down, let's have a look. Working voltage 5 volts, okay. No need for filter circuit, it can drive dot matrix. They've programmed the code for us. Number 1. Press button before power on, then power it on. IC will enter into test mode automatically. It can test LED and circuit. Okay, so first of all, we're going to find a power connector. Have I got a 5 volt power thing with one of those diddy little connectors on it? Did that, or I use the yeah, that's about right. What is this adapter? 5 volts, 1 amp, that'll do. It's one I actually haven't converted from the American style plug, so in the death adapter it goes. So what did it say? We had to hold the power button, then put the power on. It goes into test mode. Is that all the test mode? I think I'm going to do that again. So, power mode. Looks like that looks like it did something. What the other mode? S1 slow flash. Right, okay. Change display. Press the button less than 1.5 seconds. Displays an L. It's the slowest and update. Press again. High speed. So that's thinking it's got music, but it's probably picking up interference from all the lights and the bench. It's not in a box, obviously. I'm not got any. Now I know I shall get my phone, and I shall also get an audio lead. Hopefully I'll plug it into the right one. And this is the embarrassing bit where I can't unlock my phone. There we go. Right, so rocket player, hit whatever, hit play. And the music is going through there. Like that. Obviously, if I had another speaker on the output, we'd hear the output and I'd get a copyright infringement. But there we go. What you'd normally do is you'd have another, you'd have your computer speaker in here, and it would play your music through it, and you get your music there. Say whatever we've got plenty of bass. There we go. So I think a nice little lunchtime project there, and I think all we can say there is thanks very much for watching, and hopefully you'll have enjoyed this, and you can see that it does work, and it's quite a nice little display. Thanks very much for watching. Bye bye for now.